Hello and welcome to Gregory Mancu's Chapter 2, which is entitled Thinking Like an Economist. And in this chapter, we'll go into the mindset that economists have for approaching problems and discuss a little bit about the economic models that we use. And finally, end up with some of the roles that economists play and the areas that we look at. Okay? Economics trains you to be being mindful about the choices that you make, evaluating the cost of individual and social choices, examine and understand how certain events and issues are related. So let's look at the first one, being mindful. That means once you make a choice, being able to ascertain what that choice is going to mean for you and perhaps mean for others. Because economics, as we learned in Chapter 1, is all about decision making. The second thing, evaluate the cost of individual and social choices. What is the cost to you? What is the cost to others of a choice that you may make? Your decision to go to school has an impact upon lots of people, not the least of which is including yourself. It may have an impact on your family if your family is helping you to pay. It may have an impact on your young family because they may benefit in the future from the actions of your individual choice now, but they may have to sacrifice some things in the present to reap the future benefits of your decision to go to school. And then finally, examining and understanding how certain events and issues are related. There's your decision has an impact on others. United States decision has an impact upon other countries as well. Our decision to try to curb our deficit may mean that there'll be less money to spend, and that may mean that there would be more, especially in this tough economic times, more individuals unemployed. Now, we explore these things just as anybody would, but we have special terminology that we use, and we have a special lens by which we use it, and that lens is graphical analysis. And especially in this particular course, Economics 130, we use lots of graphs, lots and lots of graphs, and you'll get very comfortable with the use of graphs, specifically what we call two-variable Cartesian coordinate diagrams. So as I say here in the PowerPoint, graphs, graphs, and more graphs. Okay, economists as a scientist. Our way of thinking about problems involves thinking analytically and objectively. Analytically meaning that we break down the problem into its component parts, and objectively trying, and I emphasize the word trying, not to put our own biases into the problem. We make heavy use of the scientific method, which involves the use of abstract models to focus the discussion on a main idea or theme in the complexity of the real world. So we first come up with a hypothesis, which, as you know, is some sort of a thesis statement. What we want to prove, correct or incorrect, and then we will gather evidence to either prove that assertion correct or incorrect. And in economics, oftentimes we have to use abstract models because it's very difficult to do experimentation on the everyday lives of individuals. So I'll be talking more about these abstract models in the next couple of slides. Now, to apply the scientific method in economics, assumptions are used to make the world easier to understand. Our biggest assumption is something called ceteris paribus. which basically means all else is equal. Now, an example of ceteris paribus, as you'll see in some of the graphs coming up, are looking at two variables and two variables only. One variable impacting upon another variable. So it could be height impacting on temperature, it could be price impacting upon peak consumers buying things. Now we look at those two variables and we assume that everything else is held constant. Now one way or one thing that is ceteris paribus that's used all the time is something called commercials that we may see. Commercials are an example of ceteris paribus because commercials oftentimes want you to focus on a particular thing that is happening. Let's say it's buying bottled water, and if you're buying bottled water, they may want you to focus on the flavor of the water or what the bottle looks like or any other such things, and they want you to focus only on that, and they don't want you to focus on anything else that may have an impact upon your decision to buy. For example, do you have enough money to buy that bottled water? So the income that you may have is something that is held constant while they focus on the other aspects of you buying that water. Okay, let's go on to the next slide. And the next slide is about these economic models. We use models to simplify reality in order to improve our understanding of the world. These are abstract models. They're simplifications of reality. And in the real world, we use models all the time. A model airplane is a way to test out whether an airplane can fly, or whether to test out how an airplane handles various things thrown at it, like wind or bugs or any other such thing. Little kids use models, otherwise known as toys, to model and see how they might look in if a certain clothes was put on, or they might look if something happened to that particular model. The model itself, in this case, it may be a toy person, is meant to kind of hypothesize what you might look like if something like this happened to you. Now, folks use video games all the time, and it's the same idea. It's a model to see what would happen to you if something happened to this person in 3D. Let's say they're on a planet somewhere battling some space age creature. That is a modeled simulation. So a model, in a way, is very much like a simulation. Now, models almost always start small and then grow in increasing complexity. In this way, a model is like a machine. You're looking at one part of the machine and seeing how that part of the machine works, and then once you know that part, then you can look at some of the other parts and see how they work. And you put all these different subcomponents together, and you have the entire model for the particular machine. It could be a model car, model airplane, video game model, and all such things. Let's go to the next slide. Now we look at graphs to show models, and specifically we want to see relationships between variables. Three basic types of models that we look at. One being the time series graph, two being cross-sectional, and three being scatter diagram. I'm going to show you an example of each right now. First of all, the time series. Time series is one variable that changes throughout time. So here is focusing on our former President Bush's performance on the job, whether it was excellent or good. Now the variable that is changing is the percentage of people who thought that George Bush was doing a good job. And you can see from January of '01 to June of '06, it first went very, very high. And one could say that 9/11 had a lot to do with that. There was a little bit of a correlation there. But then it seemed to go basically down from there. Now, you don't have other variables correlated with Bush's performance on the job. The only thing you see is the change in the amount of time. And so, in order to really look at one variable upon another, we need to plot some variable against Bush's performance on the job to see if that variable had something to do with it. This does not. This is strictly time series, one variable changing throughout time. Now, this next one is kind of a humorous one I got from a website that had humorous graphs, but this is an example of a cross-sectional. So at any one point in time, here is things that you can use to keep people from sitting next to you on the bus. So, obviously the number one thing, according to this person, was the Bible. And other things: cane, large heavy bag, small child. Now this person is assuming that, one, you want to keep people from sitting next to you on the bus, and two, that the Bible is the thing that will do it. You'll notice that there's no percentages listed with this, and there's no source. So obviously the person just made this up. But this is an example of a cross-sectional diagram. At any one point in time, you can use the Bible to keep people from sitting next to you on the bus. This doesn't say, if you keep on having the Bible, will you keep people from sitting next to you on the bus, but at any one point in time. Other cross-sectional diagrams could be income distribution. Let's say in the year 1997, how many men earned incomes over $100,000 a year, or how many women earned incomes over $100,000 a year. So that would be at any one point in time. Now finally, we have something known as a scatter diagram. A scatter diagram looks at two variables linked to each other. Now on this particular graph, I should have labeled the axes. On the x, or the horizontal axis, is age, and on the y, or vertical axis, is maturity. So the x would be the dependent variable, and the y would be the y would be the independent variable, and the x would be the dependent variable, and y would be the age, and x would be maturity. So what it says basically is, as y goes up, folks are more mature as you get higher up in age. So, very, very simple graph, and one that can be hopefully proven with some data. Now what we show here is, as you look at the third bullet down, how do we show a negative and a positive relationship? A negative relationship is when the two variables, age and maturity, would go in opposite directions. So the line would be going down. It would be going from left to right. What you see in front of you is something known as a positive relationship. So both variables are going up at the same time. Now I think in your Aplia problem set, there'll be some problems with dealing with graphical analysis and showing the difference between positive and negative relationship. What you see here is a positive relationship between the variables. Now you can do a little exercise called screwdrivers and Bloody Marys. Have screwdrivers be on the x-axis, Bloody Marys be on the y-axis. Give yourself 6 shots of vodka, assuming that 1 shot of vodka would be with screwdriver would be with one screwdriver and one shot would be with Bloody Marys, and see how many combinations you can get with the screwdrivers and the Bloody Marys, and see what kind of a relationship that would be. Okay. And 2 simple rules for movements and shifts. We'll be looking at this a lot more in Chapter 4, but just keep in mind that rule number 1, when an independent variable changes and that variable does not appear on the graph, the curve on the graph will shift. So let's say we go back to age and maturity, and if something changed the impact upon age that was not, something changed on maturity that was not age, that curve on the graph would shift. It would move either in this direction or it would move in this direction. Now, rule number 2, when the independent variable changes and does appear on the graph, a movement on the curve will occur. So we go back, and we have either age or maturity changing. That change would occur along the graph here, and it would be a movement along the graph. That would be a movement. Okay, I do believe this finishes